Welcome to this video on the design of a singly reinforced beam. We will go through the problem first. Design a reinforced concrete beam to suit the following data. Clear span, 4 meters. Width of the supports, 300 millimeters. Service load, 5 kilonewtons per meter. Use M20 grade of concrete and Fe415 grade of steel. Let's summarize the given data for our design. We have a clear span of 4 meters, supports 300 millimeters wide, a service load of 5 kilonewtons per meter, and we are using M20 grade concrete along with Fe415 grade steel for the reinforcement. Next, we determine the beam dimensions. Assuming a simply supported beam, we use a span to depth ratio concept. From page no 37 of IS 456, the span to depth ratio for simply supported beam is 20, and the effective depth calculated is 200 millimeters, and an overall depth is calculated by adding effective depth and cover. Overall depth is 250 millimeters, considering 50 millimeter cover. The effective span is calculated as per IS 456. First condition is span plus effective depth. Second condition is center-to-center distance of beam, including support. Least of the two is taken as effective depth. So here, the effective depth is 4.2 meters, and we assume a beam width of 200 millimeters. For the load calculation, we first determine the self-weight of the beam. That is, length times breadth times depth times unit weight of concrete. It is calculated as 1.25 kilonewtons per meter. Adding this to the live load of 5 kilonewtons per meter gives a total load of 6.25 kilonewtons per meter, which is the service load acting on the beam. Applying a factor of 1.5, we arrive at a factored load of 9.375 kilonewtons per meter. Using the factored load and effective span, we calculate the design bending moment and shear force. The maximum bending moment is calculated by using the formula WU L effective squared divided by 8, as it is a simply supported beam, and the maximum bending moment is determined to be 20.67 kilonewton meters, and the maximum shear force is calculated by using the formula WU L effective divided by 2 for the simply supported beam, and found to be 19.69 kilonewtons. We now perform a section check by calculating the limiting moment of resistance based on the grade of the steel used in the design. By substituting the necessary values, we get the limiting moment value as 220.08 kilonewton meters, which is greater than our design bending moment. We confirm that the section is under-reinforced and suitable as a singly reinforced beam. To calculate the main reinforcement, we use the formula given in page number 96 of IS 456. By substituting the necessary values, we calculate the area of steel required, which comes to 350 square millimeters. Next, we need to calculate the number of bars by using the formula calculated area divided by the area of one bar, which we are going to use. Using 16 millimeter dia bars, we get 1.74 bars is needed, and we round it off to 2 bars. As we know that for a beam, we need to provide bars in top also. Since it is a singly reinforced beam, provide 2 numbers of 10 millimeter dia bar as hanger bars, whose purpose is to hold the stirrups only and will not carry any load. The final design is provide 2 16 millimeter bars for main reinforcement and 2 10 millimeter bars as hanger bars. Finally, we perform a check for shear. First, we will calculate the nominal shear stress by using the shear force Vu, and the value which we get is 0.49 newtons per square millimeter. We need to check this value with the design shear strength of the concrete. The design shear strength of the concrete is calculated from the table 19 on page 73 of IS 456, based on the percentage of main reinforcement and grade of concrete. Since the design shear strength of the concrete exceeds this value, the beam is safe in shear. Even though it is safe in shear, we need to provide the minimum shear reinforcement. We will calculate the spacing of shear reinforcement by using the formula SV. Based on this, we will provide 2-legged 6 millimeter diameter stirrups at a spacing of 150 millimeters center to center. This final slide illustrates the reinforcement detailing of the beam, clearly showing the arrangement of the main reinforcement bars, hanger bars, and shear reinforcement. 2 number of 16mm diameter bar is provided as main reinforcement at the bottom, and 2 number of 10mm diameter bar at the top as hanger bars, and 2-legged 6mm diameter stirrups at 150mm center-to-center spacing as shear reinforcement. With this, the design of simply supported beam is covered.